So let's go to the next question now. Question number 23. This is an important one. Figure shows two identical parallel capacitors connected to battery with switch S closed. Okay, switch S is closed in the beginning. The switch is now opened and the free space between the plates of the capacitors is filled with a dielectric constant, dielectric constant 3. So you are actually doing two things there. Initially, the switch was closed. Now you open the switch and then you fill the plates of space between the plates of capacitors with the dielectric constant 3. Find the ratio of total energy stored in both capacitors before and after the introduction of dielectric. Okay, draw the figure. It's an important question. Okay, right. So we got a pair of cells here, right? And then we have a capacitor here, capacitor number 1, right? And what else now? One more capacitor. Oh. There is a switch right here, which is initially closed. Later on, it would be opened and the capacitor will be filled with the material. Draw the figure. I'll illustrate the question. I'll explain the question, okay? Tell me when done. So we have like two capacitors. The capacitors are given to be identical. Okay, so we have two cases here. Case number 1, the switch is closed. Okay, the switch is already closed. Closed means what? Both the capacitors are in action, right? Both the capacitors are connected. All right. Case number 2, you open the switch. When you open the switch, the circuit is broken there, which means this capacitor is now disconnected from the battery. Okay. I repeat, but this capacitor is still connected to the battery. That connection is still intact. I repeat the cases one more time. In case number 1, okay, in case number 1, look at that. The switch is closed. Switch is closed. That switch is closed. Switch is closed means what? Both these capacitors are connected to the cell. They are in parallel combination. Why are they in parallel combination? Because the top plate of this capacitor is connected to the positive of the cell. Top plate of this capacitor is also connected to the positive of the cell. Look at the bottom plates. Bottom plate is connected to the negative of the capacitor cell. Bottom plate is connected to the negative terminal of the cell. Okay. Basically, if you look at the capacitors, both the top plates are connected to the positive terminal of the cell, and both the bottom plates are connected to the negative terminal of the cell. So the cell's capacitors are what? Capacitors are in parallel. So I can take case number 1. Case number 1. All right. What is the energy? I can call it energy initial. Energy can be written as half into Cp into V square. Half into Cp into V square. Why do I put Cp? The energy stored is given by half Cv square or Q square by 2C or half QV. I have 3 equations for energy. Half Cv square, half QV, Q square by 2C. My equation should involve capacitance values. Capacitance values, no? Both the capacitances are Cc. They are identical, right? So that automatically eliminates this equation because that equation does not have capacitance in it. Then between these two, I'll go for this one because this is a parallel combination. In parallel combination, who is the same? Voltage is the same, right? I was justifying why I chose this equation for energy. The energy is given by what? half Cp V square, Cp into V square. So what is it now? Half into C parallel, C and C together, C plus C into V square. So energy initial is equal to half into C plus C 2C into V square. But do not cut this 2 and 2. Instead, you call half CV square by U so that you can write it as what now? 2U. So the initial energy is what? Initial energy here is 2U. This is initial energy. I got the initial energy now. The initial energy is given as 2U. This is equation number 1. All right. I got equation number 1 now. This is equation number 1. All right. I got equation number 1. This is initial energy. Understood until here, all of you? Tell me, please. Now, this is case number 1. Hope it's clear now. I'll tell you one more time. For both the capacitors, the top plates are connected straight to the cells positive. Bottom plates are connected straight to cells negative. So, both are in parallel combination. All right. Because the switch is closed. Initially, the switch is closed. Okay. So, this is switch closed case. Okay. Switch is closed. S is closed. S is closed. Switch is closed. Now, in the second case, so it is half into Cp into V square. Capacitors in parallel. Cp means C plus C. That is 2C into V square. And for easiness, I am taking half CV square as U. That makes it 2U. Okay. Now, let us look at the second situation. Case number 2. Case number 2, I told you they are doing two things. They are removing the switch, or they are opening the switch, and then what? They are filling the capacitors with a dielectric constant 3. All right, is it 3? Is it 3? Dielectric constant 3 or 4? 3, right. So, I can write the capacitance. Capacitance was originally epsilon 0 A by D. So, the new capacitance is epsilon 0 epsilon R A by D. That is C dash equal to epsilon 0 3A by D, because epsilon R is 3. What is epsilon 0 A by D? It is capacitance, old capacitance, right? So, my conclusion is that the new capacitance and the changes would be equal to 3 times the old capacitance. 3 times the old capacitance. The capacitance values are now 3 times C. But see this, we have just broken the circuit, which means first capacitor is still connected to battery. Look at that. There is no break in the circuit, right? But second capacitor, no. Second capacitor is disconnected. Look at that. Second capacitor has what? A broken path there. It is not connected to cell anymore, right? Okay, so we have two cases. Capacitor 1. I'm writing capacitor 1. Capacitor 1 is what? This is capacitor 1, okay? Battery connected case. Capacitor 1 is battery connected case. I have told you before, when battery is connected, voltage must be constant. Battery is connected, voltage must be constant. When battery is removed, charge must be constant. Imagine somebody is giving you cash every day. One fine day he stops giving you. Then whatever amount of cash you have is a constant, right? Okay. Or imagine you're pumping water into a tank. When you stop pumping, stop the motor, the amount of water will remain constant. Same way, when battery is connected, we have done the different 32 different cases in class. Battery connected means who is constant? Battery connected means voltage is constant. So I'm finding energy now. U1F. What is U1F? Energy of first capacitor final. Energy of first capacitor final. Energy of first capacitor final. Tell me, half into 3C into V square. Why do I use this equation? Half CV square, half CV square. Because it is battery connected case. Battery connected means voltage must be constant. So I must use half C V square. Half C V square. Stop, stop, stop. Not C. What is our new C? New C is 3C. That is why I put 3C there. No. Now, earlier I put this half CV square as what? Do you remember what I put? That was put U, no? So this will give you what now? U1F will be equal to 3U. 3 times the rest of it is U. Equation number 2. This is equation number 2. I'll call it equation number 2. This is equation number 2. Understood this, all of you? So this is actually part 1 of the second section. Okay. So this capacitor is what? This capacitor is not connected now. Why? You see a broken path there, no? I open the switch. Open the switch means what? If you open the switch, that's like a broken path now. So that capacitor is not connected to battery anymore. All right, that is not connected, but this is still connected. Look at that. This is still connected. So they are entirely different cases. I'll find the energies independently. So for this one, I found the energy. How? I use the formula half C V square because voltage is constant, because battery is connected. Let's think about the other capacitor. Capacitor 2. Tell me about capacitor 2. Can you tell me about capacitor 2? It is what case? Battery disconnected, right? Battery disconnected. Battery disconnected, okay? I don't have space, okay? So I'll just leave it like this. Battery disconnected. Okay, battery disconnected means what? Who will be constant? Charge will be constant. So I'm using an equation. U2F. What is U2F? Energy of second capacitor final. Energy of second capacitor final. How to find it? I can use this equation. Q square by 2 into 3C. Why did I use Q square by 2C? Because charge is constant. Why is charge constant? Because battery is disconnected. Why is battery disconnected? Because they say that in the question. Okay, so second capacitor is a clear case of battery removed. Battery removed means charge is constant. Charge is constant means you must use Q square by 2C. But again, I use 3. Why 3C? Because new capacitor is 3C. New capacitance is 3C. You fill the space with a dielectric of dielectric constant 3. So, like I did before, what do I call Q square by 2C? That is the original energy, half CV square, which I called U, right? Original energy was called U, right? Half CV square was called U. So even Q square by 2C is U. So what do I get now? This is obtained as U by 3. I got U2F. Now I can find the total final energy. What is total final energy? U1F plus U2F. Initial energy I found already. Then final energy has 2 parts because this capacitor is battery disconnected case. This capacitor is battery connected case. So U1F plus U2F. What is U1F? It is 3U plus what is U2F? U by 3. So U1F you are going to get it as what? So U2F you are going to get it as what? U2F. U2F you will get it as, this is 3. 3 into 3, 9. So that will be 10U by 3. 10U by 3. So this is our second equation. Okay. Our second equation, 10U by 3. 10U by 3. So final energy I got. What is the final energy? I got the final energy as, this is my second equation. Okay. I got final energy. Now that I got initial energy and final energy, I can do what? I can finally find the ratio. I'll just keep these values in mind. I'll move to the second case now. I'll move to the second case. They're asking you to find initial energy to final energy. U1F to U to F ratio. What is it? U1F was 2U, U2F is 10U by 3. So it is 2U by 10U by 3. So cut them out, you're getting what? U and U are cut. Then 3 goes to numerator. It is 6 divided by 10 or it is 3 divided by 5. So U1 final, sorry, U1 final by U2 final. Sorry, U initial. What is the question? You have to find U initial to U final. Yes, U initial to U final. Okay, U initial to U final. This is U final. This is U final. Okay, U final. So what is the ratio of U initial to U final? U initial to U final is initial energy to final energy. U initial to U final is 3 by 5. Or there is a shortcut to do this. U initial to U final is given by 3K divided by K square plus 1. Sorry, 2K divided by K square plus 1. Let's check if it is correct or not. 2 into K value, dielectric constant is 3 by this is 3 square plus 1. So 2 into 3 is 6 by 9 plus 1, 10, which is 3 by 5. But the shortcut won't be useful in board examinations. This is a shortcut we give in competitive examination classes. Okay, shortcut. Okay, because this question won't be asked in MCQ in board examinations. This has come a couple of times in boards, and whenever it was asked, it was a 3-mark question. All right, it is always asked as a 3-mark question. So shortcut won't be much useful, but if you want to check if your final answer is correct, you can use the shortcut. 6 by 10 or 3 by 5 will be the final answer. So let me just put a recap one more time. We have 2 capacitors. They are in parallel, no medium in between first. They are identical capacitors C1 and C2. The switch is closed. Switch is closed means they are in parallel, right? Parallel. So for parallel combination, effective is C1 plus C2. So energy initial is equal to half into C1 plus C2 into V square. That is half into 2C into V square. I call half CV square by the name U. So that makes it 2U. I got my first major equation. Initial energy of the combination. It is 2U, right? Then you're going to do something. You're going to fill the space with what? You're going to fill the space with a dielectric constant 3. So let's find the capacitance there. Capacitance is epsilon 0 A by D. When you fill it, C dash is equal to epsilon 0, epsilon or A by D. Epsilon 0 into 3A by D. 3 into C. So the new capacitance is 3C. Keep it in mind. All right. Then these capacitors are to be treated differently now. Why? You are breaking the circuit. Now that capacitor is not connected to battery anymore. This capacitor is still connected to the battery. All right. So for battery connected case, this capacitor, battery connected case, the equation for energy is half C V square, because battery connected means voltage is constant. Battery connected means voltage is constant. So I must use an equation with voltage inside. Half into C into V square. But the new C is 3C. So half 3C into V square. Because you made some changes, right, to the capacitance. So half CV square like before, it is U. So that makes it 3U. Now I'm completely done with energy of first capacitor final. Now I still have one more capacitor there, which is not connected anymore, for which I can use the energy equation again. This time I'm using a different equation. I have a reason for it. Q square by 2C. Why? Because it is battery disconnected case. Battery disconnected means the source has gone, which means charge will be a constant. So I'm using charge involving equation. Q square by 2 into, remember to put 3C, because new capacitance is 3C. Q square by 2C is original energy, which was called U here, right? So it is U by 3. So the new energy of first capacitor is 3U. The new energy of second capacitor is U by 3. So the new total energy is, add them up, 3U plus U by 3. 3 LCM, it comes right here. That makes it 10U by 3. Once you are done, you got the final energy of the capacitors now. Now you can what? This is like 10U by 3. 10U by 3. This is 10U divided by 3. Now that you found both the energies, initial energy and final energy, the question is to find the ratio of energies. U initial to U final, 2U over 10U by 3. U's are cut, 3 goes to numerator, 6 by 10, which is 3 by 5. Now you can use the shortcut to check if your answer is correct. What is the shortcut? Ui to Uf is equal to 2k by k square plus 1. K is 3 in this question. Once it was 5. Okay, 2 into 5 by 5 square plus 1. That will be 10 by 26. Or 10 by 26. Or 5 by 13. But this time it is k is 3. 2 into 3, 6 by 3 square, 9 plus 1, 10. 6 by 10 is 3 by 5. Understood this, all of you? You can try the next question also. 24, the question is also on the same lines. Understood this, all of you?